When you're talking about half-life, you're talking about an exponential relationship. And you can model that with f of t, which represents how much you have left over after a certain amount of time. F of t equals the starting amount times an exponential rate raised to a power of time. And you always should start these problems by finding out what a is. You can get that really quickly from the half-life piece. Half it's going to be left over after 30 years. So ignoring everything else in this problem, once I'm told a half-life time, I can answer their question. I can tell them what a is, what the exponential rate is. So we can just make up our own starting amount. Let's say they did actually. Let's say they started with 4 grams. Well, half of 4 grams is 2. I'll reach that half amount if I plug in my half-life in for t, plug in 30 in for t. So I can solve for a by dividing 4 from both sides. You could have plugged in whatever number you want. Could have plugged in 10, that'd make 5. Could plug in 20, that'd make 10. You could plug in 40, that'd make 20, etc., etc. Doesn't matter, because every time you do that, you'll divide by one of the numbers and you'll get 1/2 on the left side. So we can solve for that exponential rate now. We'll raise both sides to the 1/30th power, because a power on top of a power multiplies, and that's a balanced step that will get rid of the power and leave us with just a. So we need a calculator for this. So now we got what a is. So now we can go back to the top and we can try to answer their question here. Okay, we found out that a is 0.97716. They said they want a starting amount of 10 grams. So in for k, I'm putting in 10. And they say they want to know how many years. They don't know how many years, so t is going to stay unknown. But they want to have 3.5 left over, which goes into that left side. So t is unknown. That's the thing I'm supposed to be trying to solve for. So to get t by itself, it's in the exponent position. We need a log. So we'll get rid of the 10 first, because that's a sitting duck there. 10 times something, we can undo that easy by dividing both sides by 10. And 3.5 divided by 10 gives us 0.35 equals 0.97716t. And so you can get t by itself again by taking a log of both sides. The log makes the t come down. And then if I took a log of the right side, I have to take a log of the left side. So natural log 0.35. So now that t is down, I just have one last step. That's t times natural log 0.97716. So if I divide by natural log 0.97716, that will make it cancel out here. What I do to one side, I have to do to the other. So divide by natural log 0.97716. And when you plug that in your calculator, you've got t by itself. And when you do plug that in your calculator, just to make sure you're doing it right, you should get 45.44 years.